Greetings, everybody. This is Eric Andelin, Senior Workflow Advisor with SimActive. And today I have with me my guest, Krishn Pethani, Chief Technical Officer with Nektor Engineers and Project Consultants. Krishn, say hi.
Hi, Eric. Thanks for having me, and you rightly said my name.
Great, good deal. And we're going to talk about a bunch of topics, but I mean, in general, we're going to talk about mapping, big projects, mapping in hilly terrains with drones. And is that possible, and how is that possible? Before we get into that, Krishn, why don't you let everybody know a little bit about yourself and the companies that you work with?
So we, Nectar Engineers and Project Consultant, are specialty engineering consultants, mainly focused on building the infrastructure design. And our scope starts from the feasibility of the projects till the final deliverables of preparing a tender or a detailed engineering drawings. Survey being one part of these projects, and remote sensing and GIS being one of our division, which is one of the critical factors, the divisions to all the projects and all the departments of our, where the very first preliminary job that comes in the projects is to getting the baseline survey data from the field. So we cover entirely the sector from transportation of roads, airways, as in airports, seaports, to the urban planning sector and the environmental and climate change segments. And mapping is a key to all of these sectors as we are seeing right now.
Yeah, that's absolutely true, and it's interesting that our little part of it in the mapping and survey world is kind of the beginning. I mean, there's the planning before, and then it's okay. Once we start actually executing this work, now we need the mapping and the survey to go with it. And it's fantastic. You guys get to do from A to Z, so that's kind of really neat. For the folks that are joining us, what we're going to talk about is, again, in mapping these big projects in hilly terrains, what kind of aerial platform is best for such a project? How do you consider or start your mission planning over these hilly areas? Flying both aerial platforms in difficult environments, and then managing the challenges with processing such large projects. So give folks an idea of, when we talk about mapping in hilly terrains, where are you, I know you guys fly and work internationally, but where are some of the challenging places that you guys have been?
So we would have flown and acquired the data on a various different geographical locations. The challenges would vary from the geography itself, and secondly, the content we are capturing, being it purpose for topography, being it purpose for forestry, being it purpose for water reservoirs, being one of the challenge. Secondly, the terrain where the features are at, the altitude would also be one of the larger challenge. And I would say, and we were lucky enough to have the opportunity to map as high as 6,000 meter MSL,
Wow.
which is one of the toughest job we had, and we were glad, and the team successfully completed nearly around 200 square kilometers in such a high altitude. And we were very proud that probably we might have been the first professional company. I might be wrong, but we might be that, and we finished at 6,000 meter MSL. It was a huge challenge to execute that project, and we were able to capture the world's highest post office block in that, the world's highest habitable village in that area, and it was a very great learning curve we had in terms of the data capturing, the data processing, the entire workflow. And the planning would change, your parameters would change every minute because of the change in the weather, the temperature, the air pressure, and a number of factors would kick in. And in spite of even the last day of the mapping, we were still learning with the experience that we were, getting the live feed during the capturing. So we have a vast, broad spectrum of experience with unmanned aircrafts, being it fixed wing, VTOL, being it multi-rotor, being with manned aircraft as well. We have done certain jobs, certain locations, which has been very unique, very challenging as well. So, we are very grateful that we had such opportunities, and these things are keep on coming back. And, we keep on taking such kind of challenges, which, in fact, expands our knowledge and, gives us the liberty to explore the technology and take it to the next level.
Yeah, that's 6,000 meters. That's way up there. As I was mentioning to you earlier, I was just in Colombia, and I think we were at maybe 1,600 meters. That's challenging enough for us humans to breathe, but when you start going that high, wow, that's a real challenge. So you mentioned a few of the factors to consider, but before we go down that road, I know you guys work with both platforms, multi-rotors and fixed wings, and we'll set aside the manned aircraft because that's a whole different subject. But on multi-rotors and fixed wings, what drives your decision to choose one over the other?
So in both the platforms, for unmanned aerial platform, being it VTOL, fixed wing VTOLs and multi-rotor, we have a variety of payload options that we fly for. So we fly as an optical, we fly oblique cameras, we fly 6-band multispectral, and we fly LiDAR as well. So first, it would be depending on the output that is required. That would be the very primary role of selecting it. Secondly, what terrain are we flying at? The thirdly, what season are we flying? What weather are we flying into?
Mm-hmm.
The quantum of the job, the area of a single location, being it in few hundred square kilometers or few square kilometers. This would be the very primary factors of our platform selection. Then the nitty-gritty would go into the per day production of data acquisition. If we have a longer period of time, we would have, being on a safer side, we might go with multi-rotors.
Mm-hmm.
If you are flying at lower altitude, say around 120, 140 meters, and into the hills where we have to fly such low, we might opt for multi-rotors. If we have a bit more flexibility in terms of flying in height, we would be going with with VTOLs, fixed wing VTOLs. So varies on these kind of challenges and the outputs, the turnaround time we have for the project.
Mm-hmm.
This would lead us to the selection of the platforms. It would also lead us to deployment of multiple platforms at a time on a single project, looking at the safety concerns and the operational side of the systems, the payloads, and the drone itself. So it would be a lot of factors considering it before we finalize a system or a technology that will go in flying.
So, it's okay to talk about. Do you want to name some of the platforms that you're using? Are they common ones that we would know?
Yeah, they are the common ones. So in VTOL, fixed wing VTOL, we will use systems from Quantum System, that is Trinity F90 Plus.
Yep.
And the multi-rotors is something we have, built it in-house, and we are working on that to upgrading it as per the current conditions. So that is something as a continuous process which keeps on evolving as the side of multi-rotor.
Mm-hmm.
But the VTOLs we have seen, we have tested, quite a variety of them from the OEM.
Mm-hmm.
But one of the most efficient survey grade, I would say, a machine for mass production we have seen is the Quantum Systems. Super reliable. Once you get a grip on it, it does wonders, and it flies like a beauty. So we are very happy, and the team gets excited, especially when they get to know that Quantum is getting deployed. So we really love it.
Very good. Yeah, I just finished a webinar recently with the folks at Quantum. Specifically, they wanted to chat about their it was a multi-sensor oblique camera, which has some interesting applications, and we're able to process that data in correlated 3D. So pretty interesting stuff. I agree. It's a rock solid platform. So that's good to hear. And yes, on the multi-rotor side, depending on what your payload might be, there may not be something off the shelf that you want to use when you can produce that yourself and more tailor it to what you want it to do. Getting back to, how terrain affects your choice, certainly in this world right now, it seems like everybody wants beyond line of sight and to be able to capture, large distances and things like that. But when you're working in terrain, that's not really the best idea, because once it goes over the hill, or over the side of a mountain, you kind of really can't monitor it. So I can understand, where you might want to use multi-rotors and just put a series of them up in the air in that same time frame to collect that type of imagery. Plus I would think that multi-rotors are probably a little bit more capable of adjusting to terrain as they fly. So I completely get that. So with that in mind, some of the considerations, you mentioned atmospheric conditions, weather, what else would you look at when you're making those type of considerations?
We would also look at the sun angles, the sunrise and the sunset for that, so we get a clear amount of daylight, which would be our production time. What would be looking at the change in the temperature, from the morning when your sun goes at 30° above and below 30°. What would be the temperature range between those hours? What would be the logistic from takeoff location to takeoff location, which would decide our production factors as well. Another factors you would also consider is every payload would be flying at different height and a different speed, depending on the resolutions, the accuracy that we have to submit for as deliverables to our client. So, we would have an option from flying at 6 meters per second on multi-rotors, ramping up to 14, 15 meters a second, and the quantum going almost 22, 23 meters a second with certain payloads. And the height would vary from, say, 110, 120 meters, and with the special permissions, with the flying rules and regulations in India, we can go, about the regulated zones as well with the due permission. So all these factors would lead into, our term of rules saying the production per hour would be how many square kilometers, multiplied by your 4 hours of flying. So by end of the day, are you flying 4 square kilometers? You're flying 20 square kilometers. And that would be our deciding factor, considering these things.
That's, there's 2 points in there that you brought up, and this last one, it's production hours that you have in the daytime. So that certainly is going to determine what system you're going to fly and or how many people you're going to put on a project to do this, because the first thing you brought up, and maybe not often thought of in the drone world, is sun angle. You brought up 30 degrees up, 30 degrees down. You fly inside that window, and when you're working on one side of the face of a mountain or the other, that has a huge effect on that. And then, as we know, as it warms up, that changes the atmospheric conditions, and as it cools off, it does the same thing. So I completely get how that would make a big choice in what you're looking at. And maybe even on the VTOL fixed wing side, you're talking about uplifts and downdrafts as part of that as well. They can handle it, but
and majorly when we are flying in hills, the height that we are looking at and the mountain ranges up in the northern India and the northeast of India, where we are flying, the valleys are pretty deep. So whenever you stay in a valley, you would always have wind gusts to be catered to, and does not matter your your the hill next to you, the direction you are flying. The ridge might be 800, 900 meters away, but imagine a case where you are flying and you get hit by a tailwind, and it's flying at say 20 meters a second. You get a 10 meters second wind tailwind, and it is supposed to turn. It will just run off a kilometer, 100 meters, 1,000 meters, 1,200 meters away, which the drone was not planned for. Neither it decided that it has to turn in such a way with such a high speed. Those are the challenges when we fly inside the valley, and those would become a real obstacle where you would not imagine that it can overshoot probably 1,200, 1,500 meters from its waypoint. So those things would change in a fraction of seconds, and this would all be studied detailed on the weather predictions over a history of a year or 2 years, which our engineers will also take up before they are being sent out to sites. That what were the conditions of wind patterns, the wind gust in that area for the last year or 2 years, to sort of anticipate that what might happen. So on these things, the variables are very often taken into the consideration, and they do literally change without your notice and without your concerns, and you have to deal with it.
So I would imagine that you guys are very, very conservative on your flight planning and power usage and all of those things. So with that, do you use specific flight planning software that has terrain following capabilities, or do you find that that's not good enough and that you kind of have to break up your missions based on the terrain, and say have one mission at a certain altitude and then the next one a little bit higher up as you step up or over the side of a mountain? How do you guys handle that?
So the mission planning in, again, both the platforms would vary drastically because of their own parameters and the constraints of flying of height, speed, and the range and the other factors. So for VTOL, we would use the OEM planning software, but definitely considering such a high speed and following different terrain with higher change in the altitude, the delta, we would be breaking it down into smaller areas for mission plan, which would have different parameters into it, which would be a lot more safer. We would be able to reach to our precision as well. The accuracy will be able to maintain in those factors. When we would go in multi-rotor, we would have a liberty to go onto a larger area in a single mission because of its advantage of able to gradually change the altitude because of the lower speed of the bird itself of flying up, and that multi-rotor mission plan would be done on to our custom platform, which we have developed, and we keep on improving it on time to time basis, depending on what are the situations we are handling. For us, again, it's the same point that by end of the day, one drone or one team is getting how much output, and are we running on time with the project's deliverable? Because especially for mapping and being in such geographical conditions within the India itself, you see the seasonal changes probably every 4 months. And practically we have around removing the monsoon and the peak winters up in the mountains, the snowbound areas. I would say we would around have 6 to 7 months in a year max to do the data acquisition. So the time is very short off, and we need to make sure that we are not missing out even 1 hour of a day, so that might happen that few kilometers of job is pending just because there was an early snowfall, and we have to wait another 6 months to go do the data capturing.
Mm-hmm.
So there would be definitely a lot of pressure on the team for that side as well.
I'll bet. And I know we said we would shelf the manned aircraft thing, but I can talk from my own experience. Working with aerial mapping companies in the Midwest here in the States, and the conditions to fly leaf off start in late October, and the leaves are back on in April. And don't think you're taking any vacation that time, because there's work to be done.
Yeah, true.
And in snow and things like that. So yeah, I'm sure you deal with that as well. And I guess one of the things I'd like to point out, and we were talking about, mission planning over hilly terrain. If you're flying at 120 meters over the ground and that ground surface changes by 50, 40 meters in either direction as you're flying it, you may no longer have overlap in those images, and you may find that you didn't collect it properly. So it does take a lot of planning to make sure that you're capturing the data, as you said, to meet the mapping spec. Because another thing is that if you're flying at 120 meters and that surface changes by 50 meters, you may now not meet the pixel resolution or the GSD that the customer's asking for.
Yeah.
Yeah.
So planning the mission would not always be just the safety concern. Neither the factor of, this is the minimum target per hour you need to produce or to capture. The very primary phase would be the resolution of the imagery that we need to maintain. The labs, the side lab, the front lab, we need to maintain. Because if we ignore this, or these things are not taken as top priorities, doesn't matter how much data we capture, how much images we captured, the results are going to be of no use. And once we found out in the office that things are not at par, we might not have a chance to go there again and map it off, because season have changed.
Correct. Yeah.
So there would be a very much first parameters. We also developed some validation tools of our own side. It's a very simple logical tools, with some basic coding and algorithm, with some basic input of parameters of terrain and the sensors, fitments, and the flying parameters. It would be able to show us the footprint of images right before, like at this time of mission planning. And this would allow us to see literally that, if you plan out, say, 50% side left, for example, we would be able to literally measure in that output that are we really getting 50%, or are we getting just 10% in this zone.
Yeah.
So then, the trajectories or the block has to be broken down again into the pieces and found out that, are we really getting the data set or not. So that's a validation tool we have, thought of, and we truly believe that there is one of the major factor that is, getting the job done in the first phase of capturing. And I don't recall that we would have gone for recapturing for any of the projects. I think since more than a decade we are into this, not a single day of project I remember that you have to go fly again because there was an issue in the planning.
So that's music to my ears. Project planning is, you can't go wrong with it. You can never do, too much of it. And it's great to have created tools that your operators can load and look at and say, yes, I have the coverage I need. Show that to you, get your sign off, and then before they start flying, you're comfortable in what you're doing. So
okay.
That leads to we talked about choosing the right platform and what you might consider there. Considerations in mission planning. So we have that. Flying. We talked about flying the platforms in different environments. Now let's talk about the back end side of it. So all this data has been collected. What do you do with it? How do you bring it all in? How do you manage it before and then when you start processing?
So that's another world now we coming into, data processing. And the very primary thing that comes into mind is the data handling, the very first side. You know, Imagine you are, flying a 40 megapixel sensor or a 60 megapixel optical sensor, and you're producing thousands of images, per hour. Each image is around 50, 60 megabytes. And, we cover up around, say, 20 kilometers a day. The end of the day, you're talking about, few GBs, 50, 40 GBs a day,
Yep.
Multiplied by 6 days a week, multiplied by, a month into 6 months. That's the huge challenge to handle those data sets, getting into the office, and then leading it to the data processing. So even that part is taken very seriously into consideration of planning. So this has initially it has a correlation between the data capturing and the data processing. So optimization of flight plan also happens by the number of triggers, the number of images that would be covered in an area. Because, for example, if the same block of an area is being captured with 20% more images, it would also lead us to the extra resources of production of imagery. It might be an overkill as well into the stitching and overlapping of the images into the software. Higher number of images would also require extra resources, computing powers. So it would be an overkill. It would be, a wastage of your time and resources as well. So number of images into the area, into a square kilometer, would also be equally considered right from the flight planning. And the processing team would also be involved into the planning stage because of these footprints and the number of tags that would come in. So we would have seen, depending on the sensors, we would have seen on a thumb rule of per square kilometer, an image of around 400 or 450 as an average case. We have gone higher number of triggers up to 800 images per square kilometer, and we've gone as low as 300 or 280 images a square kilometer. So the output and the turnaround time on the data processing would also vary a lot. And again, that would be something we call it as mass production, because the amount of data that the team is capturing, it has to have a quick turnaround. Then the entire cycle gets justified. That's what we feel. That if the data acquisition team is doing 40 kilometers a day, the processing team should be at par or probably higher than that, because there is a lot more process to be done, from data generation to merging to QC to final submission. So there are a lot more activities to carry in. And that is one of the very serious factors, we'll always consider. And we go for all these payloads and sensors, apart from LiDAR. We are, a lot more choose to a single platform that we are currently using, and these factors would definitely be a very demanding factors to consider in the turnaround time.
Okay, yeah, and I mean, sometimes more megapixels is not a good thing. So it it does allow you to fly higher, but it may be less images, but it may be a larger data set to work with. So I see how you have to weigh your options there. But from what you're saying is you guys do some really strenuous pre-flight planning to collect the appropriate amount of images needed based on the GSD or what the deliverable is to the client. You're capturing, in some instances, that one project may consist of 20, 30 flights with multiple drones. So you're probably minimizing the overlap, but making sure you have it. So when you merge them all together, there's no gaps and things like that.
Right.
And I know you guys are one of our users of Correlated 3D. So I'm sure you use other software as well, but bringing that in, I mean, there's some tools within correlated 3D too to help in the validation process. Obviously, when you go into AT, you can see all the flights and things
Right.
like that, and do some editing and so forth. But maybe you could talk a little bit about, how that workflow occurs on your end.
Right. So the data processing software, firstly, I think we would have tested and tried majorly available softwares in the market. We had a varied experience depending on the software to software. And at last, we landed up on the Correlator 3D, and the way we worked on it, and the time to time, we have always, able to find out a very feasible solution to the process. And that is why we are, I think, since a long time we have been sort of dedicatedly working on the Correlator 3D. So again, it's the turnaround time for us maintaining the accuracy and the precision that we are looking at. So if you look from the flight planning till the deliverables, every process, every tool should be able to carry forward that accuracy and precision to the next level, to the next process. If one of the processes misses out on the accuracy and precision, the previous activities are of vain. If the software is not able to, process the data which has the accuracy and the precision, the data capturing is of no good. In the Correlator 3D, we have seen there's basically two workflows, the automated and a manual one. So, and we have, always felt that if you have sort of a manual or a semi-auto sort of workflow in the any process, you would have a lot more control about your deliverables. You have a lot more parameters to choose, because when we're dealing with a data set, which is typically from a high altitude area or a mountainous range, your workflow cannot be the same of the same data set that you have captured today and the captured tomorrow.
Yeah.
Because your images will change, your angles of the altitude will change, your steep angles will change, your iteration angle changes up, your color histogram changes because of the sunlight, the features on the ground changes. So there's a lot more variables. If it's a flat land, a lot of things gets eliminated and we can have a single, workflow which will work for the entire area. So having that control of, manually choosing or semi assisting a semi-auto process to deal with this data set and to do a validation on step-by-step basis to make it clear that how we deal with is every step, right from the image cleaning till the extraction of mosaic.
Yeah.
We have created a process of QC at every single stage. So the images have been filtered. There's a QC that has to be followed that is it good enough. Then once we do the AT, there would be again a sort of a checklist that would go, and a QC would be done that is it this good enough to go further. So at the end of the project, we do not fall into a zone where the data is of an issue. Doing a repetitive process of same data set again would hamper my mass production, I would say. So a time has to be well spent on each and every stages in order to meet those deadlines, and the amount of the quantum we have right now, and since last few years, we cannot fall short on the deadlines that we have committing. So we have to make sure that everything goes from single process, nothing has to be redone, and and especially with Correlator, we have seen I think one of the fastest turnaround time for a data set. And I remember the first time I had seen the trials with your team, and we were pretty amazed that how fast the turnaround can be. And we were always in a question that why these softwares are taking so much of time to even do a basic overview processing of an imagery. Does not make sense. Of course, everyone has a different take. Everyone has a different formula to process it.
Yeah.
But finding out that software which is capable to do it, it was really exciting for us, and right from day one, we started testing it to a very great extent. Until today, we have a team dedicatedly testing the software itself on different scenarios of our
Yeah.
workflow.
Yeah.
So that the team has no relation to deliverables, but it has, the aim of testing into a different terrain, different parameters, understanding each and every single functions and options that has been given into correlator. So we with your support team as well,
Yeah.
they get very much hands on, that we need to understand why this has to be turned on or this has to be turned off, why exactly these numbers, just so that we know that we are getting best out of it.
Yep.
The software is capable. It's just that we have to understand as well. And so we have a single license or a team that is allocated to just understand. And I think it's almost quite long that that resources is been spent off, and we still expect that as because even the software grows as well.
Yeah.
You releases the patches, you releases the updates.
Mm-hmm.
So we also have to be on that pace. We have to be updated with the new changes that comes in.
Yeah.
And we would not be able to utilize 100% unless we know that how it works.
Mm-hmm.
And we have seen fantastic support from the team as well, and they also get excited
Yeah.
that we always come up with something new challenge, and
Yeah.
and there's always something new aspect to it.
Yeah.
So and in that way we have found out a very great support from the team as well, and the expertise that your support team has is always on the point. And we also get some feedback about what improvements can be done on the data set as well.
Mm-hmm.
So that's entirely a teamwork that happens, and that's what we truly believe, that it's never a one-man show. It has to be a team that probably directly or indirectly works for a project. And the team might go from the supporting level to the front face of the project. So they all have to be on the same face. So we're quite happy with that.
Well, I'll tell you that even on our end, we're not a big company. We're a good size company. We're the right size company, and I work with the support team all the time. I work with the sales team all the time, and I can tell you we're all excited when we have an update that brings something to our customers, and we hear back, how this is helping them and making their lives easier. So, we always appreciate the feedback. But you did mention that, I mean, there's a handful of ways you can process in correlated 3D. You can do it in the manual mode, step by step. You can do it in an automated mode if you want. You can kick things off and come back later. You can do it, directly from scripts if you want. So you've got all those options. Once you're comfortable with them, you can move forward with those. But I think you've answered all my questions about this topic, and I really enjoy the conversation. I appreciate your time. Have you got any final thoughts?
So thanks for having me, and it was a wonderful chat with you. It's the experience that what we have captured, and what we have gone through. It's a wonderful journey that we have passed, and looking forward to having such new challenges as well, which leads us to go an extra mile to deliver rather than to give up the job. There are certain places where we might have a comfort from the client as well, that if it's too difficult, you can leave it off, you don't risk it. If the team is having a challenge, to go there. But I think till now we have not backed off from single challenge, and that has been the main task and the main focus, that there would be always a learning curve. Would not necessarily that we would come out of it, but at least we would learn, and we would can implement something like that in the next phase. And this applies to the mission planning, to data capturing, as well as to data processing. There has been times where the software is giving the same sort of probably errors or same issues in the same data set. But there was one mentor one fine day told me, he was a LiDAR expert, and he told me that as far as you have a data set, there is a way around to work on it. It's just that you have to find out the way that is there. if it's a blank data, you cannot do anything.
Yep.
So, and that what we always kicks in when we go to our lowest low, that, we should give up.
Yeah.
We always think back that we have a data set.
Yep.
We would be able to do something, but it's just that the idea is not coming in, that how it would be processed or how it would be captured.
Yeah.
And I think that's the key factor that keeps on, going through these challenges. And I still strongly believe that despite of, flown or captured so much of, hundreds and thousands of square kilometers up in the mountain ranges with such a variety of altitude change, we still believe every single day of flying, it's a new experience.
Yeah.
Because, it's not a typical terrain. A lot of things would kick in and change, so we always feel that, it's a learning curve, it's a stepping stone that, day to day we would learn it. And I think we would not consider ourselves to be the experts of experts in the mountains, but we would always follow that learning curve and keep on upgrading and see how efficient we can be in those areas. And for sure, we definitely love to work in those areas because, for others, it's a holiday destination.
Yeah.
It's a vacation place.
Yeah.
So we get everybody to go there very often, stay for a longer period, explore the tradition, the culture, the weather, and, be away from the metro cities, the big towns, from pollutions and, the noise and all. So it's an added health benefit as well that we get into it.
Yeah.
So we definitely love those areas.
Well, I think you brought up a point is we're not all experts here. We're just people that are pleasantly occupied doing this type of work. And I hope through our interviews, our webinars, and our podcasts that we can share some of that information with folks. And as I said before, I really appreciate your time and enjoyed talking.
Yeah, likewise, Eric. It was really wonderful.
Great. Well, thank you very much. Okay, well, let's jump into a bit of a demo where we can talk about some of the key considerations you might look at when working with large projects in Correlator 3D. All right, so let's take a look at a data set. Now, we don't have one of Krishn's data sets from the Himalayas, but let's talk about some of the things using a different data set that covers some of the same kind of issues. So here we have a large data set. And this is in a hilly area, and we could take a look at the 3D view to see that. So here is our 3D view. We've got an area that's got a lot of elevation, and we can look at some of the same issues. Now, first off, we could start by looking at, as we discussed, GSD. So when you're working with an area with elevation, there are two ways to fly it. You can fly it at roughly the same altitude and make sure that you have enough overlap and coverage so that you could still get, stereo overlap. The challenge there is that your GSD is not going to be from the closest point to the altitude of the images, but it's going to be from the farthest point. And that's because software can only have or imagery can only have one GSD. So when the software goes to work with it, it has to go with the lowest common denominator, which would be, in this case, somewhere down here. And I can turn off the model and load the DEM, and we can kind of see that. So down here is the lower side of the project, as you can see, which means the GSD is going to be related to what it captures down here, not what it captures up here. So something to consider. Now, a way that you could change that, obviously, is to set your mission planning up so that you are capturing at ground following altitude. So if you had, for example, a DSM to load into your flight planning software, then you could tell that software, okay, here are the flight lines, make sure the flight lines follow the terrain. If you did that, then your GSD would probably be a better resolution. And that would work out just as well. So you have to consider that. You consider that with, the slope of the project, In this case, the project is running, along a ridge line and over, say, in this case, it's a castle. So that's the direction of flight that they wanted to take. But if you have a bigger project with more terrain, your direction of flight would more likely be perpendicular to the hillside, and it would step up as it goes up the hillside. So in that case, you would want to do, again, terrain following, or make sure that the altitude that you fly at is good enough to cover the area, each image overlapping in stereo, given the elevation. And we can look at that a little bit here. Let me go back to the DEM. So again, we can look at this. This over here is the lower side of the project. This is the higher side of the project. And as we look at our footprints, we're seeing footprints that are large on this side of the project. And let me turn off the DEM so we can see that better. So again, this is the side of the project that is lower in elevation. This is the side of the project that is higher in elevation. And you can tell, looking at the footprint, okay, over here, for example, if we look at this one, towards the top of the project, that footprint is much smaller than if we went down here at the bottom of the project and looked at the footprint. And the reason for that is because the distance between the camera and the ground is greater here than it is over here. And where that becomes a challenge, and hang on, I'm going to flip back over to the 3D view. There we go. Where that becomes a challenge, I'll tilt this over, again, is that if the distance between the camera and the ground becomes small enough, you won't get stereo coverage. And that can really wreak havoc on your projects. So if you're going to fly at one altitude, make sure that altitude is high enough to be able to give you stereo coverage where it's closest to the image, yet still give you the GSD that you want, knowing that the GSD is going to come from the surface that is farthest from the camera. Or your other option, again, is to do terrain following, where your flight lines will follow the terrain and maintain an altitude above terrain. So say, 200 meters above terrain, it'll be 200 meters here above terrain. It'll be 200 meters here above terrain. Your GSD will come from a common number. So definitely keep that in mind when you're setting up projects. Now, the last thing I would comment about that is, and again, flight planning doesn't happen in Correlator 3D. Flight planning happens in your own software that came with the drone or UCGS or something. A lot of times when they ask you if you want terrain following in those softwares, they are using an existing terrain data set, which is probably the SRTM data set captured in sometime in the 80s. And the nice thing about that is it's available all over the world. The bad thing about that is that in a lot of places, it's not that good. So make sure you account for that. If the accuracy is plus or minus 20 meters, make sure you account for that in your flight plans. Make sure that you keep that drone up above that additional elevation. Anyhow, those were my comments and demonstration on what you have to be aware of when you're doing large projects in hilly terrain. I hope that my demo helped you understand some of the concepts. And thanks again to Krishna for joining me. If you did leave a question during the webinar, we will answer that as soon as possible. And a reminder, this webinar, our interviews, and our podcasts are all available on simactive.com under the Learning tab. Thanks again for joining us. Until next time.